With today's internet-based technology infrastructure, things move really quickly. And it's very important to have fixes, updates, and new software rolled out as quickly as possible with as few bugs or security problems as possible. This is where the concept of continuous integration comes in. There was a time when most software was written by one or a few developers in a group. Often they worked in the same location and they were in contact with each other directly quite frequently. It was relatively easy to coordinate responsibilities and divide labor. It was still important, though, to develop revision control systems that both kept track of changes but also enabled more than one contributor to work on a project at the same time and to handle it in a rational and sane way and avoid conflicts, etc. In order to do this, Central Repository was created, which stored the master copy of a project, and then developers could check out that copy, make changes, and then check them back in. The problem of having two people work at the same thing at once was rather special and eventually became more and more important, and people developed techniques for working with that. The first really hugely distributed development project was the Linux kernel, where literally people are all over the world, and these days there are thousands of people. The Git revision control system was invented by Linus Torvalds himself in order to rationalize this kind of distributed development. But a revision control system still doesn't solve the problem of making sure that things actually work. If you have people working on different parts of a project from different angles and locations, it has to mesh together and not conflict, and solving one problem should not create another one in another area, etc. You must have testing in order to do that. So if you're doing testing, you have to consider a number of questions, such as can you apply changes that overlap with each other at the same time? Do they conflict? If so, how do you resolve those conflicts? Does the project actually still compile, and can it be produced once you apply all the changes? What about all the possible targets? A lot of people working on a project only work on one kind of architecture or one kind of device, etc. You have to actually define what it means to work. And are there good test suites that can be used with a representative workload to make sure things are actually working and give you some confidence that things are okay? What continuous integration techniques do is they ensure you test constantly and frequently, that any problems which develop are quickly resolved, and developers and users all stay on the same page. Usually people distinguish three separate stages to continuous integration. There's continuous integration, continuous delivery, and continuous deployment. The idea with continuous integration is to constantly merge any changes into the main branch of the software and to run automated compiles and builds with as many variations of platform, software, hardware as possible, so that any conflicts are nipped in the bud before they become rather bad. The continuous delivery phase means that once you have integrated changes, you have a quick and automated process of delivery or release, and it's released to consumers of the build. This might be companies, etc., that are using the software, which are going to distribute to end users. And that is done in the third phase, continuous deployment, where you release the actual product to customers. So sometimes continuous integration means all three phases together and includes both delivery and deployment. So here's a little graph that shows you how it all goes in a continuous circle. The time gap between the steps is meant to be as close to zero as possible. In some cases, developer changes can even reach user customers in the same day or even within minutes or hours when everything is working very cleanly. Now, the benefits we have talked about, and they're relatively obvious, but there are also significant costs to continuous integration. If developers have to constantly integrate their changes, that's a possible strain on developers because they constantly have to feed their work up to other people even before they're finished completely. Of course, the benefit there is you don't go too far down a wrong path. You can catch mistakes before they get baked in and get in the way of other people. Another cost is that you have to construct what's called a continuous integration server. There has to be staff allocated to do this, to handle this whole process of continuous integration. The benefit here, though, is that everything is fully automated. All the work has been done up front, and so you don't have to just do a build each time. It's all very automated. Another cost is that scripts and other tools have to be written so that you can perform these tests, etc. And it's a lot of work to set up such an infrastructure on a complicated project. But the benefit is that you minimize bugs, or what are known as regressions, which are bugs in features which used to work. You can minimize that, and hopefully your releases are more bug-free. There are many tools that are used for continuous integration, complete suites of software that help the whole process. Jenkins is the most widely used, and we give a list here of some of the other main ones such as Travis, TeamCity, GitLab, CI, Bamboo, etc. Some of these are free, others are not.